Okay, guys, so let's start over chapter number 4, part B. It's the continuation of the previous lecture. So in this part, we have mainly three things to discuss, starting with the ARP protocol, address resolution protocol. Then we will be talking about DHCP, and we'll discuss few application layer protocol like FTP, TFTP, HTTP, HTTPS, and some other stuff as well. So I'm assuming that everybody has already watched the previous video where we discussed the TCP/IP model, we discussed OSI model, and we discussed various stuff of the other routing protocols as well. So now next is these three protocols that we're going to talk about. Before we jump into ARP protocol, ARP, so let's quickly let me give you a definition of ICMP protocol. ICMP, first of all, it stands for Internet Control Messaging Protocol. So ICMP, it mainly provides two main utility. First of all, ICMP protocol, it works on over internet layer of TCP/IP, where if you remember in TCP/IP we discussed fourth layer is application layer, then we have the transport layer, then we have internet layer, and then the last one is the network layer. So ICMP protocol, it falls in internet layer. So Internet Messaging Control Protocol, it mainly offers two utilities. The one utility is called trace route, and the second one is ping. So it offers these two main utilities. Ping, I hope everybody already familiar with ping. Ping is mainly, it is used for troubleshooting plus test connectivity between hosts, two or more hosts, two hosts in fact. So that is basically what we use the ping, and it's very simple. You just have to type ping and the domain name or the IP address, and you can send the ping packet over that particular host just to see whether you are connected with that host or not. Then the trace route, it basically it shows you all the hop counts, and you can see how many routers or gateways are involved in between you and that particular host. So that's basically the trace route is for. And hop counts or routers are mainly called default gateway. Default gateway is basically your router through which you are connected with internet. So let's say this is your computer. If you are connected with ISP, or through ISP you're connected with the internet, so you might have a small local area network at your home. So router or default gateway, that's the gateway, it connects your local area network with ISP and eventually with internet. So if this default gateway is not configured properly, or for example if it is configured incorrectly, then you can, or host can communicate with devices on local area network but cannot communicate with devices over remote network. So what does it mean? Let's say if this router is not configured properly, so you can still communicate with the devices within your local area network. You can send ping packet to other devices because you need to know the ping, you need to know the IP addresses, MAC addresses, but you cannot communicate with the device which is located over internet if your default gateway is not configured, set up properly on a host. That was ICMP protocol, which runs on internet layer. So now let's move to our main agenda item, that is ARP protocol, address resolution protocol. Address resolution protocol. Okay, firstly, let me give you the definition of ARP protocol. It runs on your network layer, or for OSI, it runs on your data link layer. So Arp protocol, what it does, it mainly resolves, that's the definition, resolves the IP address into MAC address, or you can say it basically Arp protocol, Arp maps destination MAC address to destination IP address. So that's basically what the Arp protocol, what exactly it does. And for local area network, we use Arp protocol because it provides the MAC address. Because as you know, for local area network communication, let's say this is your local area network. For local area network communication, devices, they need to know the MAC addresses of each other, and how they can get the MAC addresses of nearby devices or local area network devices by using Arp protocol. Okay, address resolution protocol. Each device, it has an Arp cache. In that particular Arp cache, they store the MAC addresses of the local area network devices. Let me give you a basic idea about Arp protocol, how exactly this protocol works. So for example, let's say we have a local area network and I have plenty of devices connected over this local area network. For example, I have a device, IP address of this device. This is, let's say, computer A, that's computer B. And we have many other devices connected in a local area network, Ethernet based local area network. For example, we have computer A, then for example, we have computer C, we might have computer D here, we might have computer E. There are plenty of devices, for example, here. So computer A, IP address is 1.1.1.1. B, its IP address is 2.2.2.2. MAC address of A is AAA. MAC address of B is BBB. Okay. So for example, this is IP address and that's the MAC address. Again, MAC and IP. Same is the case with other computers. Now, for example, computer B just joined the network. And now computer A wants to send a ping packet to computer B. Okay, so what does it mean? Computer A wants to send a message to computer B. So if you want to send a message to computer B, computer A will create an Ethernet packet. So we will create an Ethernet packet here. That's, let's say, Ethernet packet. And what will be Ethernet inside the Ethernet packet is encapsulated kind of packet. In this packet, we have we need to know the source IP address, source MAC address, destination IP address, destination MAC address. Okay, so source IP, and again, that's basically your packet. So like you can say the data or whatever you want to transmit, for example. Source IP addresses, we know that sources like this computer 1.1.1.1, and the source MAC address is AAA. Okay, we know the destination IP address because, I mean, we want to send, we know there is a computer, and that's why we know the IP address. So we know the IP address 2.2.2.2, but currently we don't know the MAC address. Okay, how we can find the MAC address, or computer A will find the MAC address of that device. Computer A will broadcast a request which is called Arp Request. It will broadcast Arp Request. So that request, everybody will receive that request. If you guys run Wireshark, start capturing the packet, you will see there are plenty of Arp requests might be in your network. So what is Arp request? Arp request is computer A is saying, hey, my IP address is 1.1.1. My MAC address is AAA. I am basically looking for the MAC address of 2.2. If anybody knows, please reach me out. That's basically how the Arp request looks like. Now everybody will receive it. All the computers on the network, they will receive it. B will also receive that request. When B will receive that request, B will update its Arp cache. This is called Arp Cache, like kind of storage thing. If you want to see your Arp cache, open your command prompt and type Arp space -A. Now what will happen? It will update its Arp cache, and in Arp cache there are you have IP addresses and the MAC address of the devices in your network. So it will store it like 1.1.1. Its MAC address is AAA. For the future reference, if I want to send anything to A, so I can pull the information from my Arp cache. Now what will happen? It will send its data to the ARP response to A as well, like, hey, I am 2.2.2 and my MAC address is BBB. After computer A receives the ARP response, it will also update its ARP cache, like put this particular entry and put down here, like the MAC address is BBB, and send the packet now to that network. So this is basically called ARP protocol. This particular protocol works on the data link layer. For local area network communication devices, they need to know the MAC addresses of each other. And how they find it, they'd use ARP protocol to populate their ARP cache and then use ARP cache to send or broadcast the packets. One thing which is very important regarding ARP protocol. Now, for example, let's say this is, let me make a scenario. Let's say I have this computer. Let's say this is my computer A. And then let's say I have another computer, for example, computer B. So let's say I have two computers, computer A and computer B. Computer A is in this network, for example, at this particular network, which is where we are connected with this router with internet. And computer B might be, let's say, in a remote network, another network, might be connected with another router over there. So this is network 1, and this is might be another local area network, remote network. So computer A wants to, let's say, send a ping packet to computer B. Now what will happen? Computer, since we want to send a packet to this, we will create a packet. We know the source IP address, like we know that over IP address, we know the source MAC address, we know the destination IP address, we don't know the destination MAC address yet. What will happen? We will broadcast a ping packet, ARP request. Over router will respond back, hey, okay, so for you, I know the destination, where the destination is, but MAC address is going to be me. So I will be able to receive the packet. So the MAC address, destination MAC address is going to be the router's MAC address. Your router will respond back with its own MAC address. Okay. So that's basically how our packet looks like. And that's the way how if you remember, we trace it like where we designed the TCP packet. If you remember, we designed the TCP packet by putting all those information. There is an attack which is called Arp Spoofing Attack. Arp Spoofing Attack is basically impersonation attack. Impersonation attack, where attacker, what it does, attacker modifies the ARP cache of all connected devices to point to his computer for local area network communication. Now let me make a scenario and let me explain you what is ARP spoofing now. That's a definition, by the way. ARP spoofing is basically, for example, let's say there are two people in a network. We have, for example, this is Bob, and let's say this is Alice. So Alice and Bob. So for example, Alice IP address is 1.1.1.1 and Alice MAC address is, for example, AAA. Okay. Bob IP address is 2.2.2.2 and MAC address is, for example, BBB. So they are connected with the local area network. I'm assuming that. Now let's say over hacker or attacker, he joined the network. So let's say this is attacker who joined the network. Now attackers, for example, IP address is 3.3.3.3 and MAC address is the general MAC address is, let's say, HHH. For example, that's the MAC address. Now how attacker can actually launch a ARP spoofing attack, impersonation attack. Attacker will, after joining the network, attacker will send fake ARP request, or you can say fake ARP messages, start spreading the ARP messages across the network. Attacker will reach out to Alice and say, hey Alice, do you know Bob? No, Bob MAC address is, the new Bob MAC address, the previous Bob is gone, like the guy who has the BBB, he's gone. The new Bob's MAC address is HHH, which is basically his MAC address. Alice, she will respond back to hacker, say thanks. And now what she will do is she will update the ARP cache, like IP address is again 2.2.2, but MAC address is going to be HHH for Bob. Hacker will do the same thing with Bob. Reach out to Bob and say, hey, do you know Alice? Alice MAC address got changed. The previous Alice is gone. She's disconnected now. The new Alice MAC address is HHH. The new computer came in. Bob will again say, thanks. And now Bob will again, his IP address will be, update the Arp Cache IP address and MAC here, like 1.1.1.1 for Alice, but MAC address is going to be triple H. So now what will happen if Bob wants to send any message to Alice? Who will receive it? Hacker. If Alice, she wants to send any message to Bob, who will receive it? Hacker. So that is called man in the middle attack. Interception. Now, whatever hacker wants to do, they can actually, he or she can do. He can steal information and some other stuff. We will use a tool called AtterCap. We'll use a tool, AtterCap, to demonstrate Arp spoofing. If you guys wanna practice Arp poisoning, there is a tool which is called Burp Suite. So please do use that Burp Suite as well. It will give you the basic good overview understanding of the man in the middle attack. But we're gonna use AtterCap. The next is the DHCP, Dynamic Host Configuration Protocol. So it stands for Dynamic Host Configuration Protocol. What is basically DHCP? In DHCP, there are two types of IP addressing. Like if anybody joins a network, there are two types of IP addressing. Firstly, you can assign a static IP address to somebody, or you can give a dynamic IP addresses. Dynamic mean whichever IP address is available, you can give to the new host. Static mean if you have a host with certain level of privileges, you can assign him a permanent IP address which can never get used. What I'm trying to say is, let's say this is over the network server, for example. We got a lot of IP addresses, 1.1.1.1, 1.1.1.2, 1.1.1.3, 1.1.1.4, for example. Let's say we have these 4 IP addresses. So in the dynamic, what will happen? So I can maximum accommodate 4 people, 4 computers. So if anybody joins a network, okay, so I will find whichever IP address is free, I can assign that IP address to him. If a next computer joined in, so I'm basically left with these IP addresses, 3. So I can pick whatever is available, I can assign to that. Same is the case. So when all the IP addresses will get full, so I will unable to accommodate the new host. Now, for example, in the case of static or in dynamic, what will happen, for example, if this particular IP address, this computer will disconnect with internet or doesn't, let's say, just leaves the network. So IP address assigned to this computer will be, free. Like the server will reclaim this IP address and will be available for the next person who wants to access that. Static mean, let's say this is the IP address. I have assigned this IP address to this computer, regardless of whether this computer is connected with the network or not. Nobody can use this IP address because this is dedicated to this computer, and I'm left with these 3 IP addresses now. So that is called static. But in a local area network, we use mainly dynamic host configuration protocol. What is that? So let's say, for example, you just join a network. Once you join the network, there is a DHCP server, and that server has plenty of IP addresses. When you join the network, you will reach out to DHCP server and say, hey, hi, that's my MAC address. Can I get an IP address so I can start using internet? DHCP server will look into IP addresses and see if there is free IP address. If there is a free IP address, DHCP will make a request. DHCP server will make an offer. They will offer you, hey, I have 1.1.1. Do you want that? Then what will happen? Your computer will respond with DHCP request. Yes, please, I want it. Then what will happen? They will assign you the IP address. This is basically called how the DHCP protocol actually works. So the definition of DHCP is it provides logical addressing, and IP addressing. And again, when host receives, like this host received DHCP offer from server, it responds with DHCP request. Request means like, hey, yes, I will be grateful if you can please assign me that IP address. That's request. These are some application layer protocol. I hope you guys are already familiar with these protocols. FTP, file transfer protocol, port number 2021. And FTP is basically used for uploading and downloading. Like a secure uploading and downloading, you need a login, secure. TFTP, trivial file transfer protocol, trivial file transfer protocol, port number 69, and it's basically UDP. That's TCP, of course. UDP, insecure downloading or uploading. It's kind of like, for example, you have uploaded a PDF file on a link. If anybody visit that link, automatically file will get downloaded. That's TFTP. Simple mail transfer protocol. And we use SMTP for for mail processing, email processing, or you can say transmission over the network, and it also defines the formatting as well. DNS, domain name server, what it does, it manages and provides domain names and IP addresses. Basically, it resolves the domain name into IP address. So let's say www.gtc.edu. So that's a domain name. So DNS protocol, what it does, it translates the DNS into IP addresses, because if you want to access any computer over internet, you need to know the IP address. HTTP hypertext transfer protocol, what it does, port number 80, and it controls how the web page will be displayed. HTTPS secures, it's basically again hypertext transfer protocol, secure. It mainly uses the SSL, TLS sometime. That's the technology what it uses, and it encrypts the message before it leaves the network and all that. So it's kind of the same thing, but it's in a secure fashion. We will see in the lab when we will use Wireshark. You will see the Wireshark and the working of HTTPS, the benefit of HTTPS as well. So that's it about our chapter number 4. So we are done with that. If anybody will have any question, you can always let me know, please.